So now, if you saw the last video, you're going to see basically the same circuit that we did in the last video, except instead of an NPN bipolar junction transistor, now we're using a PNP bipolar junction transistor. So we're using the 2N3906. It has most of the basic properties of the 2N3904 when it comes to a bipolar junction transistor for how much current it can handle and everything, except for its polarities are opposite. So you see the emitter is to the positive supply, arrow is pointing in now because it's a PNP, and a collector has the load towards the negative side right there, opposite of the NPN. We still give a signal to the base. Now we got the capacitor here. So when I press the button, first thing, capacitor starts charging, but also transistor looks like it's almost turning on instantly right there, pretty much instantly. That's because we only got a 100 ohm resistor right there. So we get up to about 0.6 volts pretty quickly when it comes to charging the capacitor. And we charge up the capacitor pretty quickly. When I release the button, the capacitor discharges. So again, there you can see it's discharging. There's less current flowing over time. And actually, let's go that way. Positive to negative there. We do have a diode drop, emitter to base right there. And so as current dwindles its way down, less current flows through the load. It's still many times as much current flowing through the load as is moving through the capacitor right there and the emitter to base. And then when we close it, that gets the negative side of the capacitor there, so the gray band, a connection to ground right there. So you still got to put the capacitor in the right way, and even though positive is going to a supply, it is still the positive side of the capacitor. It's the positive supply right there. And so always be aware of that. Whichever end is going to the supply rail, that's the side of the capacitor that should be attached there. And we got a resistor over here, a switch, but that's negative over there, right there. But when I release this, now we have a path going that way, right there. So we need to put the positive side of the capacitor to the positive supply rail. Hopefully that makes sense. But yeah, we have a 100 ohm resistor, again, so that the capacitor charges really quickly right there, at least enough to get the transistor on, and then it may, it'll charge a bit after that, but in any case, it's still pretty quickly. 100 ohm resistor, it's only 100 microfarad capacitor, and so that is 1 microfarad would be 1/1,000,000th of a farad, very small amount, and this is 100. So we charge that, pressing the button, release it, then we have that path there. Again, much more current flows through the transistor, emitter to collector in this case, because we got the positive supply to the emitter, than the little bit from emitter to base. Many times though, up to probably about 200 times, I would say. So if we have 1 milliamp of current flowing this way as it fades, it's probably 0.002 milliamps of current flowing through the load. And we'll look at the power supply right here, and we should see that we'll get like 12, 13. This isn't as accurate as a multimeter. Milliamps of current, almost instantly. So looks like it took a little bit to ramp up, but the LED lit pretty well. And then we release the button, and it will fade down again. So not too complex, but it is a kind of a transistor switch, but we get a signal that gets weaker over time. Thus it lets less current through over time. But as always, it's many times, maybe 200 times, maybe 100, maybe 300 times as much current from emitter to collector and through the load as is going emitter to base, since this is a PNP. So hopefully all of that makes sense. I'm using 220 ohm resistor to protect the LED because we're using 5 volts right there. The transistor, when it's saturated, it doesn't limit current. So we need the resistor and the diode to limit current. That means we got enough current emitter to base to get the transistor to conduct better than what the load needs. And so that's the basic way it goes for a switch. Now, when current trickles down through emitter to base where we can't provide as much current as the load wants, so the transistor starts cutting down how much current flows. That's called the active region of the transistor. That's when the amount of current flow is related to the gain of the transistor. So that would be, you know, for how much emitter to a base current's going through, how many times as much current can go emitter to collector. That would be the saturation region right there. You know, just something to be aware of. It's not really something you can calculate. Maybe, you know, if you do a lot of math. But for now, just realize that that fade down that you see is due to the gain. You know, the current got so low, you can only get so many, you know, times as much current to flow from emitter to collector as you have to emitter to base. So a higher gain transistor would keep the LED lit longer, and but it would still fade down sooner or later. And a transistor with worse gain, you know, like a lot of really large transistors I see, they don't have all that much gain. The LED would fade a lot quicker, all other things being equal. So in any case, yeah, pretty simple circuit. So I mentioned a bunch of other stuff. Again, it's all stuff that you read and takes a while to absorb, but hopefully you still enjoyed. Make sure you check out one of the other videos I posted on the screen and check out the links down below. They all help a lot. I'll see you in the next video.